Find the x-intercepts, corresponding zeros and their multiplicities, and the y-intercept of the polynomial given. Use this information along with end behavior where necessary to provide a rough sketch of the graph of the polynomial. So let's start off with this first factor, x plus 1. What makes that 0 is negative 1. And the exponent 1 is the multiplicity. Moving to the next one. What makes that term 0, that factor 0, is positive 1. And the multiplicity is the exponent 2. And finally, the third factor, negative 3, makes that 0. So the 0 is at negative 3. And its multiplicity is 1. So the x-intercepts are, the zeros are x values, negative 1, 0, 1, 0. And negative 3, 0. So we can put those values on our graph as dots on the x-axis. Okay, now I'm just going to plot one point. If I plug in 0 up into this, we have negative 2 times 1 times negative 1 squared times 3, and that is all negative 6. So the y-intercept, I can now tack on here 0, negative 6. This should be enough information for us to finish the sketch of this graph. Let me demonstrate. 0, negative 6. So the graph is down here and it needs to get up to these x-intercepts. Now the negative 1 x-intercept here is multiplicity 1. Multiplicity 1 means that it's going to cross like a line, a straight line, an x to the 1, like a mx plus b. So as it's going up this way, it's going to cross like a line. At positive 1, multiplicity 2, that bounces like an x squared. So as we're coming up to this one, it's going to bounce like an x squared and go back down. Now at negative 3, again, multiplicity 1, it's going to cross like a line. How far up does this go? You could plug in negative 2. It goes way, 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 way up. But for a rough sketch, I'm just going to turn it around right about there. It's not correct. It should be way up higher, but that's not the point of this. The point is to know what it looks like around the intercepts. So this is going to come down and cross like a line because the multiplicity is odd. Now multiplicity 3 would actually cross like an x cube. So knowing the multiplicity tells you how it interacts at the x-intercept, whether it goes through like an x to the 1, a line, or it goes through, bounces like an x squared, a parabola, or it crosses like an x cubed, which we don't have any multiplicity 3, but it has a little x cubed wiggle as it goes through. These multiplicities allow us to sketch these polynomial graphs, assuming we have the zeros, quite nicely.